This is according to 5054 course, and this is according to 0625 course. मैं इसको side by side इसलिए put किया so that you could easily make the comparisons of it. I don't know why it's not putting together. Okay. पहली थिंग है उन्होंने बोला है कि आइडेंटिफाई करें व्हाट इज मेंट बाय नॉर्मल एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्लेक्शन। अगर हम एक मीडियम ड्रॉ करते हैं, इसके ऊपर 90 डिग्रीज एंगल ड्रॉ करते हैं, दिस perpendicular line to the surface is known as normal। ठीक है, किसी भी सरफेस के ऊपर 90 डिग्रीज का आप एंगल ड्रॉ करेंगे और परपेंडिकुलर लाइन ड्रॉ करेंगे, दैट इज नोन एज नॉर्मल। The light traveling or the wave traveling ray, this is ray, traveling towards the surface with an arrowhead pointing towards the surface, this is known as incidence ray, and the angle I is known as angle of incidence. It's always made between the normal and the ray. Always make sure that the angle that you draw should always be between the normal and the the ray and the normal that we have drawn. The second is reflected ray, ray moving away from normal, reflected ray, and the angle is known as reflected. Are we clear about reflected angle and everything? और जो हमने रिफ्लेक्शंस ऑफ वेव्स प्रॉपर्टीज के अंदर पढ़ा था वो पॉइंट यहाँ पे भी इनपुट होगा कि एंगल ऑफ इंसिडेंस इज इक्वल टू एंगल ऑफ रिफ्लेक्शन। ओके, can I go to the next one if this point is clear to you?
आपने स्क्रीन कौन सी खोली हुई है? आपने 3.2 लाइट कंटिन्यूस खोली हुई है?
आई थिंक सो मेरी स्क्रीन शेयर नहीं हो रही आप लोगों को, सॉरी। अब दिखा सब कुछ?
हाँ जी।
क्या मैं दोबारा से बताऊं, ये समझ में आ गया है?
दोबारा से बताएं।
अच्छा, दिस इज द मीडियम। मीडियम पे जो परपेंडिकुलर ड्रॉ करते हैं उसको हम लोग क्या नाम देते हैं? नॉर्मल का नाम देते हैं। रे जो मीडियम के टुवर्ड्स पॉइंट आउट कर रही होती है और ट्रैवलिंग टुवर्ड्स द मीडियम, दैट इज नोन एज इंसिडेंस रे। और जो एंगल वो रे नॉर्मल के साथ बनाती है उसको क्या नाम दिया जाता है? एंगल ऑफ इंसिडेंस। रे that is moving away from the surface is known as reflected ray, and the angle which it makes with the normal is known as reflected ray. Always keep this in your mind कि ये वाले angle and ये वाले angles consider नहीं होंगे। Angle of incidence and angle of reflection is always between the normal and the reflected and the incident. Am I clear now?
हाँ जी।
अहमद, आप भी थोड़ा इनपुट दे दिया करो बेटे, ताकि मुझे पता चलता रहे दोनों को समझ में आ गया।
Yes, sir.
या नहीं समझ में आया?
Sir, just can you describe incident ray को फिर से बताइएगा?
मतलब जो रे ट्रेवल कर रही होती है टुवर्ड्स द सरफेस, दिस रे ना,
Towards
फॉर एग्जांपल दिस इज द सरफेस and I am considering this ray and this ray. The ray which is moving towards the surface is known as incidence ray, and which is moving away from the surface is known as reflected ray. एरोस बने हुए होंगे, डायग्राम्स बनी हुई होंगी, या आपसे डिमांड करेगा फिर इंसिडेंट पे। इस तरह के क्वेश्चंस नहीं आते, जस्ट टू आइडेंटिफाई व्हिच वन इज एन इंसिडेंट एंड व्हिच वन इज अ रिफ्लेक्टेड रे। सो वेव व्हिच इज ट्रैवलिंग टुवर्ड्स अ मीडियम, एंड आई वाज टेलिंग यू कि ये एंगल रे का सरफेस के साथ है, सरफेस angle. ठीक है? And this is also with the surface. If this angle is given as 60, normal मैंने आपको बताया is an angle which is drawn perpendicular to the surface. If this angle is given as 60, तो ये वाला angle कितना होगा? How much would that angle be? Hello?
वो भी 60 नहीं होगा?
60 minus 90 क्या होता है?
60 minus 90 30.
हाँ, तो ये एंगल क्या बनेगा? 30. बिकॉज ये पूरा एंगल कितना है? 90 का. और इसमें से इंसिडेंट एंगल कौन सा है? What would be the value of incident
What is
angle?
this? Left side वाला इंसिडेंट है.
इसकी वैल्यू क्या होगी अहमद?
60 होगी.
60.
यस.
रिफ्लेक्टेड एंगल की वैल्यू क्या बन रही है?
60 बन रही है.
रिफ्लेक्टेड एंगल 60 है, 30 है? मैंने अभी भी आपको बताया कि एंगल हमेशा नॉर्मल एंड रे के बिटवीन होना चाहिए, सरफेस एंड रे के बीच में नहीं होना चाहिए.
ओके सर, तो हम इसको 90
So-
से माइनस करके निकालेंगे.
Yes, if it's not given, if this 60 angle is given, this means I have to, because this angle 60 is between the ray and the surface. In order to find out the angle between the normal and the ray, we have to subtract it from 90, because normal is making a 90-degree angles with the surface. And if the arrow is pointing away, that means that is a reflected angle. So that is 30. And we know that incident angle and reflected angles are both equal. So incident angle would also be 30. Okay. So point 1 is common in both the syllabuses. You could see right in front of you that both point 1 is common in there. Describe an experiment to illustrate the angle of reflection. I have just explained you this is how I would justify incident and reflected angle. Measure करेंगे हम लोग उसको, and we would compare both the angles, and if incident angle is equal to reflected angle, this is known as law of reflection. Law of reflection tells us that incident angle is equals to reflected angle. We will take a mirror, we would point a ray towards it. Okay. The point at which it touches the surface, I would draw a 90 angle, and with the help of ray, with the help of pencil, I will trace this ray. मैंने ये with the help of light ray यहाँ पे लेके आया. Once that, and I would obviously by the mirror it would reflect back. So I would draw the reflected ray as well with the help of pencil. Once this is done, I would switch off the ray box, and with the help of protector, I would measure this angle. So according to law of reflection, this angle should be equals to this angle. If this is justified, if these angles are equal, it means law of reflection is being followed. Did you get the point? Or do I need to repeat it?
Yes, sir.
Fatma?
I got the point.
Describe an experiment to find the position and characteristics of optical image formed by a plane mirror. And the properties of an image formed by the plane mirror is that they are of same size, they are of same distance, and images are mostly virtual. So जब भी there is an image formed by the mirror, these would be the characteristics of the image. So if the question comes, we should be able to describe it. Exact the same point here, that the image formed by the plane mirror, the characteristics would be same size, same distance from the mirror, and would be virtual. So point 3 is common. Point 3 and 2 exactly the same. State that for reflection, the angle of incidence is equals to angle of reflection. ये भी point हम लोग discuss कर चुके हैं. use simple construction measurement and calculation for reflection by plane mirror. ये experiment हमने अभी recently discuss किया. And you could see here in this syllabus as well. State that for reflection, the angle of incidence is equal to angle of reflection, and this is मतलब calculation हम लोगों ने करनी है. Now, जो third point है, उसके ऊपर हम image draw करके देखते हैं कि I have shown you कि ये सारे points common है in both the syllabuses. Suppose this is the mirror. We have this mirror. I have this object. There are two rays coming from this object. These rays are incident rays. Now, what I need to do is the point at which they touches the surface, I would draw a 90 degrees angle like this and would measure these angles. Suppose this came out to be 20 degrees and this came out to be 50 degrees. What would be the reflected angle for ray 2? Fatma, this is ray 2, this
30.
is ray 1. Why 30? Incident and reflected angles हमेशा क्या होते हैं?
Equal.
Yes. So I would, with the help of D, I would measure a 50-degree angle and I would draw the reflected ray at 50 degrees. Similarly, this was a 20-degree angle. So with the help of D, I would draw a reflected angle of 20 degrees like this. Now, उसने properties of image made by the वो क्या रखी हुई है कि object distance D1 should be equals to distance of image. D1 is equals to D2. Now, I would trace back these rays up till it meets like this. Yeah. आप जब इनको trace back करेंगे, ये naturally they would meet at this point, and hence we will have the properties, characteristics that the distance of object and distance of image is equal. Image, virtual images कौन से होते हैं? Virtual image formed on the other side of the mirror. ठीक है? We could clearly see that these rays are not actually meeting at this point, but we have traced them back to this point. So such a image or such a rays are known as virtual rays, and the images formed by such rays are known as virtual images. That the rays are not actually meeting here, we had to trace back these images to build the image. So same size, if the object is of, let me draw it with the help of an arrow. This is the, अच्छा, there are another point that we need to keep in mind कि virtual image होता है, sizes same होते हैं, sorry, distance of image from this mirror is equal to distance of image from the mirror. D1 is distance of object from mirror, and D2 is distance of image from mirror. अब एक चीज रह गया जो कि जस्टिफाई करने के लिए हमें साइज जिसका ध्यान रखना पड़ेगा. फॉर दैट, सपोज आई हैव अ 2 centimeter object length is 2 centimeter. One ray is coming from top and one ray is coming from bottom. ठीक है? अब again, the point at which they touches, वर्चुअल इमेज की एक और प्रॉपर्टी होती है जो कि मैं आपको इसके एंड पे बताऊंगा कि होल्ड ऑन बेटे फॉर 1 सेकेंड। यहाँ तक image formed by mirror are normally virtual in nature। उनकी प्रॉपर्टीज ये होती हैं कि सेम साइज, सेम डिस्टेंस फ्रॉम मिरर, and they are always upright। Upright means if the object is like this, the image would also be formed exactly like this। For example, it's like this, image would exactly form like this। Inverted का मतलब ये होता है कि if object is like this, image would form like this। This is upright and this is inverted। So these are the following properties that we need to keep in our mind whenever we perform the experiment। I will show you everything like in less than a minute, where all these points हम कैसे justify कर रहे हैं। ठीक है, अभी जो हम लोग करने लगे हैं वो तो you could see in the diagram, ये जो हमारे पास ये है, this one is known as ray box। अब this is the ray that is moving towards mirror, ठीक है, and this is the reflected ray। We could clearly see that कि which one is an incident wave or reflected ray। If the examiner asks, देखो अब समझ में आ रहा है इसमें डायरेक्टली डायग्राम में कौन इंसिडेंट है कौन रिफ्लेक्टेड है।
हाँ जी।
ठीक है, अब इस वीडियो को गौर से देखिएगा आप, ये हमारे पास मिरर है। हमने क्या बात की थी कि ये वाला यहां से नॉर्मल ड्रॉ होगा, ठीक है, दिस एंगल एंड दिस एंगल शुड बी इक्वल टू ईच अदर। ये लॉ ऑफ रिफ्लेक्शन है। ठीक हो गया। अभी देखना हाउ ही मूव्स द मिरर अक्रॉस और कैसे एंगल ऑफ इंसिडेंसेस चेंज हो रहे हैं और उसके अकॉर्डिंगली रिफ्लेक्टेड एंगल्स भी चेंज हो रहे हैं। लुक, देखो मिरर मूव कर रहा है एंड कैसे रेस के अंदर वो चेंज हो रहा है। ये हमारे पास रे डायग्राम्स होती है, इसको रे बॉक्स बोलते हैं एंड हमने ये जस्टिफाई करना है। अब देखो वो आपको स्टेप बाय स्टेप बताएगा। ये आपने उसने सरफेस ड्रॉ किया जो मैंने आपको ड्रॉ करके दिखाया था, उस सरफेस पे उसने मिरर प्लेस किया। अब वो रे बॉक्स उसके टुवर्ड्स मूव करेगा। ये उसने रे बॉक्स को मूव किया एंड एज आई टोल्ड यू कि विद द हेल्प ऑफ पेंसिल हम लोग लाइंस ड्रॉ कर लेंगे। अब ये रेज आ रही हैं, ये रिफ्लेक्टेड रे आ रहा है। ये देखो ये वाला आपका इंसिडेंट रे है, उसने पेंसिल की हेल्प से ही उसने लाइंस ड्रॉ कर दिया एंड रिफ्लेक्टेड रे को भी उसने विद द हेल्प ऑफ पेंसिल्स ड्रॉ कर दिया। ठीक है, अब वो रे बॉक्स को ऑफ कर देगा। ठीक है, और उसने रे बॉक्स को ऑफ कर दिया तो जो उसने जो लाइंस ड्रॉ किया था वो विद द हेल्प ऑफ स्केल उसने अब क्या कर दिए, उसको कंप्लीट कर दिया। अब विद द हेल्प ऑफ डी he would draw 90 डिग्री एंगल्स और मेजर करेगा ऑन ईदर साइड के विद रिस्पेक्ट टू 90 क्या इंसिडेंट एंगल। अब मैं यहीं पे स्टॉप करता हूँ, आई स्टॉप राइट हियर। 90 का नॉर्मल, ठीक है, दिस इज द 90 डिग्री एंगल विद द सरफेस। ठीक हो गया। अब वी कुड क्लियरली सी के ये देखो ये एंगल क्या बनेगा, 10 डिग्रीज, 20 डिग्रीज, 30 डिग्री एंड यहां से हमारे पास क्या बन रहा है, ये 30 डिग्री, 31, 32, 33, 34 एंड 35। सो ये एंगल कितना बन रहा है, 35 डिग्रीज का। रिफ्लेक्टेड एंगल पे कितने डिग्रीज का बनना चाहिए, 35 डिग्रीज का। सो ये आ गया 10, 20, 30 एंड अभी उसके हाथ आगे आया हुआ है तो मैं दिखाता हूँ अभी उसमें, वो आपको मेजर करके दिखाएगा। ठीक है, इंसिडेंट एंड रिफ्लेक्टेड एंगल, hence proven कि incident and reflected angles are equal to each other। और with the now do you guys get it कि law of reflection कैसे होता है।
हाँ जी।
how do we use ray diagram और कैसे हम लोग वो करते हैं। अब मैं आपको दिखाता हूँ. In the following experiment, this experiment help you understand image formation. See, object is like this, and image is exactly like this. This is known as an upright image. ठीक है? Upright, and upright images are mostly virtual in nature. You could see this is 9.5 distance, and image distance is also 9.5. ठीक हो गया? That if an object is placed at a 9.5 distance from the mirror object, the image will also be formed 9.5 centimeter away. So the total distance between image and object would be 19 centimeter. Because 9.5 plus 9.5 would be 19 centimeter. Am I clear up till this point?
Yes.
अब इसके अंदर इसके अलावा बाकी वो चीजें मैंने आपको जो बताई थी कि हम विद द हेल्प ऑफ बाकी चीजें हम लोग उसको नहीं कर सकते, वो हम लोग वर्चुअली आपको एक्सप्लेन करते हैं कि दिस इज ऑब्जेक्ट एंड वी शुड बी केयरफुल के इमेज का डिस्टेंस भी. तो हम जब रेज ड्रॉ करेंगे we will take this into consideration. I normally ask my students to draw two rays like this and take them back and join them. आप पहले से if this is 9.5 also to 9.75 centimeter image and two rays लेके आने मीट करवाएं यहाँ पे and ये reflected rays आप ले जाएं. ये आप obviously dotted lines draw करें. Angle of incident, angle of reflection equals रखें. ठीक है? Now let's see further into this experiment. ये देखो, ये अब इन्वर्टेड इमेज बन रहा है हमारे पास. ठीक है, object is like this, or you could see the image formed on the white screen behind. See, it's the upside down. We will get into detail of this image as well. This is known. अब ये जो आपको दिखाएगा, ambulance is written like this, and when you will see this word in the, ये lateral inverted होगा. So images formed by the mirrors are lateral inverted. Lateral inversion का मतलब मैं अभी आप लोग देखो lateral inversion का मतलब क्या होता है. Straight होगा. ठीक है, उससे पहले कैसे थे? It was like this. And lateral inversion का मतलब बेटे ये होता है कि whenever you would see an image like this, let me go back to the section which we were studying. For example, B is written like this. When I would see this in the mirror, it would look like this. C would look like this. D would look like this. This is known as lateral inversion. And images formed by mirrors are laterally inverted. इस वजह से ambulances के ऊपर हमेशा words laterally inverted लिखा गया होगा. Because when we see in the back mirror, तो हम उसके अंदर ये करेंगे. Am I clear up till here?
हाँ जी, but what is this emblance? What is जो एम्बुलेंस वाला है इसको हम क्या बोलते हैं जो आपने भी दिखाया है?
Lateral inversion
मेरा
बोलते हैं इसको. Lateral images formed in the mirror are laterally inverted. तो उसने सारे वर्ड्स ऐसे लिखे हुए थे. लेफ्ट राइट इन्वर्जन इसको कहते हैं. ठीक है, left
हाँ जी।
light invariant, lateral invariant is known as left right invariant. Now this would be, I would draw this angle incident, उसके accordingly मैं refracted angle draw करूंगा, trace back करूंगा, it would meet to this point. Again यहाँ पे normal रखूंगा, I would draw the reflected ray and it would be meet this point. So size of image, if the object is 2 centimeter, size of image would also be 2 centimeter. If distance is 9.5 centimeter, distance of image would also be 9.5 centimeter. These are the properties of waves that we, light, how light and mirrors act. Okay, so we have completed the reflection of light, first basic points. I think so. I forgot to share my screen. You were not able to see all these things, but मैंने verbally वो point explain कर दिए थे. Lateral invariant बोलते हैं इसको. You could see how. Okay.
हाँ जी।
इतना portion record भी कर लेता हूँ. There are two waves, types of waves. Waves को हम define किस तरीके से करते थे अहमद? And जल्दी जल्दी आंसर करना है. अहमद and फातिमा on point रहना है. फौरन फौरन जवाब करना है. Waves. How do we define waves?
Sir, it is a
For now, I'm
Waves,
phenomena which
asking.
transfer.
it is an
Yes. Ahmed.
Yeah. Sir, it is a phenomena which transfer energy without transferring medium.
Yes. It is a wave is defined as a phenomena which transfers energy without transporting medium. That is, only energy is transferred, no kind of matter is transferred whenever we are talking about waves. Okay? So wave is a phenomena which transfers energy without transporting medium. How many types of waves do we study in our syllabus, Fatima?
two types of waves: mechanical waves and electromagnetic waves.
Can you differentiate between these two?
Mechanical waves are dependent on medium, and electromagnetic waves are independent on medium.
Very good. So waves are further divided into mechanical and electromagnetic waves. Dependent on medium are known as mechanical waves, and independent of medium are known as electromagnetic waves. The examples are sound and light. So mechanical waves are further divided into two types. What are those, Ahmed?
Longitudinal wave and transverse wave.
Longitudinal and transfers. Shanze or Shazer, do you guys have idea what longitudinal and transfers are?
Yes.
Longitudinal waves कौन सी होती हैं जो compression and rarefaction की forms में travel करती हैं, and अहमद, transverse waves कौन सी होती हैं? They travel in the
Sir,
form of
transfer in the form
crust
of
and trough. ठीक है? Compressions are basically the compressed part of the wave, and rarefactions are these parts. So these are compression and these are rarefaction. So one compression and one rarefaction is one wavelength. Similarly, this is crust and this is trough. So one crust and one trough combines to give one wavelength. So coming back to the light, that light is a form of energy and it's an electromagnetic wave, but at the same time, it is also transfers in nature. Transfers hone ka that doesn't mean that it is medium dependent. It's only because it travels in the form of crust and trough. It is medium independent, but it travels in the form of crust and trough. Light travels in multi directions. So whenever we would show light, it would go like it's going in every direction. We normally draw like this. This shows that it's going in every direction. On the contrary, sound mostly travels in straight line हमारे पास. So, light की nature हो गया electromagnetic. There are three properties that we study about light. One is reflection that we discussed in the previous lesson. We discussed that reflection is basically when light bounce back to medium one after hitting medium 2. That is, we would show light as if this is the incident ray. The point at which it touches the ground, that is, at that point we draw normal. And this is the reflected way. Incident, reflected, and normal. The angle between normal and incident is incident angle, and the angle between normal and reflection is reflected angle. And they are always equal. Incident and reflected angles are always equals to each other. The second thing that we discussed in the previous lesson was the formation of image. Whenever we form an image, what points do we need to keep in our mind? I'll start with Fatma. Whenever you're drawing an image, what points do you need to keep in mind? Hurry up.
Points such as कि normal surface, ये वाले points.
नहीं. कि
Okay.
डिस्टेंस क्या होगा, इमेज कैसा फॉर्म होगा, वर्चुअल इमेजेस क्या होते हैं, दैट अहमद.
Wh-
ऑब्जेक्ट एंड इमेज का डिस्टेंस क्या होगा?
सेम होगा.
A distance and B distance should be equal. सेकेंड हमने क्या करना है, कोई भी रैंडम सी 2 रेज लेके आनी है. These would be considered as incident waves. अब what I have told you guys कि कैसे हम लोगों ने काम करना है इसके ऊपर. There was this scale यहाँ पे that scale available. Anyhow, I couldn't find the scale right now. Normally हम लोगों ने scale put करना है, and we would make sure that scale is put in such a way that these are drawn like this and like this. These are drawn like this. It should meet at this point. और यहाँ पे. और as I told you before, कि the point at which they touch the surface, वहां पे normal draw करना है हम लोगों ने 90 का angle, ऐसे और ऐसे, and we should keep in our mind that incident angle and reflected angles are always equal. अब ऐसे vertical image हो और इस तरीके से image हो, दोनों ways में हम लोगों ने एक ही ध्यान रखना है कि object distance and distance of image is always equal, and we take any two random rays like this. The point at which they meet the surface, वहां पे हम लोगों ने normals draw कर देने, and then we जब normally आपको the examiner asks you to draw the images, you do not need to make everything up to scale. It's just कि you should know. हाँ, अब ये लाइन आपकी स्ट्रेट चली जाएगी और विदाउट मूविंग द स्केल आपने इसको क्या कर देना है, trace back कर देना. Similarly, this would go straight and you would trace back the point and at which they will meet. हमारे पास full हो गया. So in the previous lesson हम लोगों ने ये किया था कि object distance and image distance is equal from mirror. ठीक है. सेकेंड पॉइंट हमने ये डिस्कस किया था कि वर्चुअल एंड रियल इमेजेस क्या होते हैं. वर्चुअल इमेज की प्रॉपर्टीज क्या होती हैं? अगेन इन टर्म्स ऑफ मिरर, व्हाट आर द प्रॉपर्टीज ऑफ वर्चुअल इमेज, अहमद?
Sir, virtual image cannot be formed on a screen,
वेरी गुड.
and
And
virtual image is produced by rays.
every image is formed by rays, but it cannot be formed on the screen. And second इसकी property क्या होती है फातिमा? Would you like to add anything to it? हम लोगों ने एक वर्ड के रेफरेंस से बात की थी कि that is the indication of virtual image. What do we call it? Lateral inversion होती है. Image is laterally inverted. For example, if B is written like this, we would see its image like this. If we see this, it would look like this. This is known as lateral inversion, and this is the property of the virtual image. ठीक है? Lateral inversion and upright. Upright means ये होता है कि if object is like this, it would appear exactly like this. जिस तरह है बिल्कुल उसी डायरेक्शन में when drawn, that is known as upright, not inverted. This is known as inverted. If I draw it like this, sorry. अगर image exactly ऐसे होता, this is object, this is inverted, this is upright. ठीक है? So virtual images are upright, cannot be formed on the screen, and laterally inverted. Now, to understand cannot be formed on the screen, just get the idea. If the image is real and that image is being produced on some kind of a screen, if you put your hand in front of it, if the image is formed on your hand as well, such an image is known as virtual real image. If the image you stop looking, you cannot see the image anymore, such an image is known as virtual image. For example, the image formed by the जो images formed जो projector होता है हमारे पास, projector idea, do you guys have idea about the projector?
Yes.
Yes.
So when we stand in front of the projector, that image starts forming on us. Such an images are known as real images. If the image stops being formed, such an image is known as virtual image. And the second category is जो virtual images होते हैं, virtual images are always formed on the other side of the screen. Other side of screen. And second important point इसके अंदर ये होता है, rays do not actually meet. ठीक है? As we could see कि हमने rays को trace back किया है. These rays are not actually meeting here, but we have traced them back. Such an images are known as virtual image. Are you clear about the virtual image and everything about reflection? We have spent most of the time in revising the previous topic. Let's jump to the reflection. Reflection is a very lengthy topic and Fatma's favorite. Again, we are going to discuss shallow to deep, which means denser to rare and deep to shallow, which is rare to denser. There are two things that we need to keep in our mind, as I've written right in front of you, whether the rays are entering from denser to rare medium or rare to denser medium. In this particular, when it comes to light, denser medium is mostly glass or water, and rare medium is air. Okay? So we need to see whether light is entering from air to glass or from glass to air. Refraction is exactly defined the way we have discussed before. It is the bending of wave into the other medium. For example, we have this medium. This is air. This is water. We would draw a line. We would draw a normal. We know this angle is 40 degrees and we know it's going into water. So instead of going, this is the path, the dotted path is the path without bending. Matlab it's going straight. Okay? But it would bend towards normal like this, and incident angle is greater, than reflected angle. Here it's reflected and incident. Okay. The way to find out this angle, we're going to discuss in the later stage. Similarly, if the air is entering from glass to air, this is the path which the ray would have without any change of medium. This is incident angle. And it's entering into air. So when it's entering into air, it would go away from normal. So incident angle is smaller than refracted angle. Can you guys remember only this part? Okay, when it's going from air to water, the ray would bend towards normal and incident angle would be greater than refracted angle. When the ray is entering from glass to air, it would bend away from normal and incident angle would be smaller than refracted angle. Just memorize these points. Can I go to the next part now? Can you keep this point in your mind, Fatma and rest of the students?
हाँ जी.
Okay. Now the formula that we use to find out incident or refracted angle is N is equals to sine I over sine R. We put a hat on it to show it's an angle. And when it's going from glass to air, it is represented used this angle. Now, we need to see what is meant by N. N is known as refractive index and it is given as Ahmed, do you recall what refractive index is? Can you guys hear me?
Yes.
अहमद को आवाज जा रही है मेरी? Is he even in the class?
Yes, he's in the class.
Anyhow, Shanze or Shezer, do you call what refractive index is?
Yes.
What it is?
What are
Speed of light in vacuum divided by speed of
vacuum board है वो क्या
light
बचा है?
in medium. It is represented as C over V. So N is equals to C over V. C की value fix होती है, which is 3 into 10 raised to power 8 meters per second. N and V की value unknown होती है. So whenever there will come a question, he would give you at least two values and you need to find the third value from it. Okay. So these are the two formulas that we use to find out the incident or reflected angle or refractive index too. I would show you the question what kind of questions they are going to be in the exams. But are we clear? यहाँ तक सब okay है?
सर रिफ्लेक्टिव इंडेक्स का समझा दें दोबारा।
ये रेशो
ये
होती
एन
है. हाँ,
ये
it is
एन का
defined.
मतलब
हाँ, it is defined as the ratio of speed of light in vacuum over speed of light in that medium. For example, light when enters from air into that medium, what effect would it have on the speed of light due to change of that medium? For that, we take help from refractive index. Everything would be given. I will show you the questions as well, okay, what kind of questions are going to come in the exams regarding these. But you need to keep these concepts in your mind, only then you will be able to solve these questions immediately. So refractive index is basically defined as the ratio of speed of light in air to the speed of light in that medium. If, for example, light water air से water में enter हो रही है, it's entering into air. So what would be the speed of change in the speed of light when it would enter from air to water? Okay.
ठीक हो गया।
So the third formula that we need to understand is, and the last formula and the last thing of today topic is total internal reflection. This phenomena occurs at a certain incident angle. How to find that incident angle that would make total internal reflection possible? अब total internal reflection is हम discuss करते हैं in case of transparent mediums. Normally, it's expected that in a transparent medium, we cannot keep light in. ठीक है? अब फॉर एग्जाम्पल एक ग्लास की शीट है, उसके अदर साइड पे हम लोग लाइट को फ्लैश करते हैं. Do you think you would not see that light on the other side? Obviously, हम ये expect करेंगे कि लाइट जो है, we could see it from the other side of the glass, but there is a way through which we can reflect the light from the glass surface instead of it refracting. For that, we need to understand what total internal reflection is. What I'm talking about is this. Okay, this is light, this is air, this is glass. Normally, it is expected that it would refract into the other medium. But there is a possibility through which we can keep the light. I need to write it like this: glass, glass, and air. अब when I have to see that the light could be reflected back into glass. For that, I need to understand about the properties of incident angle. ठीक है? अभी अभी हमने डिस्कस किया, we just discussed that कि when glass glass कह रहा हूँ, when light we discussed these points कि इंसिडेंट एंड रिफ्लेक्टेड एंगल की प्रॉपर्टीज क्या होती हैं. इंसिडेंट एंगल इज स्मॉलर देन रिफ्लेक्टेड एंगल, which means के there is a relationship between incident and reflected angle. That is, by changing incident angles, we could create some kind of a change for reflected angles as well. So there is a term used which we call critical angle, and critical angle is defined as that angle of incidence for which the refracted ray makes an angle of 90 degrees with normal. अब नॉर्मली क्या होता है कि हम लोगों ने इंसिडेंट एंगल ड्रॉ किया and we get a certain refracted angles. ठीक है? But this incident angle would be called a critical angle if ray, instead of going to this side, it would make a 90-degree angle with the normal. Such an angle of incidence for which the refracted ray makes an angle of 90 with the normal is known as critical angle. And when incident angle is greater than critical angle, this phenomena occurs. Total internal reflection. And now the question arises, how would we know, how can we calculate the critical angle? Okay, how can we be sure that for this particular medium, the critical angle is this? Suppose for that, the formula that we use is 1 over sine C. If the examiner has given us the refractive index of that medium, we would rearrange this formula and we would find the critical angle. Normally for glass, जो critical angle होता है वो 42 to 45 degrees का होता है, which means कि अगर ये glass है मेरे पास और अगर मैं 42 degrees के ऊपर रे को इंसिडेंट करवाता हूं तो मेरे पास रिफ्लेक्टेड रे कैसे बनेगी? इट वुड मेक एन एंगल ऑफ 90 विद द नॉर्मल. वो ऐसे मीडियम के बाहर नहीं जाएगी. सच एन इंसिडेंट एंगल जो हमने कैलकुलेट किया फॉर विच द रिफ्लेक्टेड रे इज मेकिंग एन एंगल ऑफ 90 इज नोन एज क्रिटिकल एंगल. थोड़ा समझ में आया व्हाट क्रिटिकल एंगल इज, फातिमा स्पेसिफिकली? ओके, लेट्स रिव्यू फ्रॉम द सिलेबस के रिफ्लेक्शन ऑफ लाइट के बारे में जो अभी हमने पढ़ा, उन्होंने दोनों सिलेबसेस के अंदर क्या बात की हुई है. सो इन ओ लेवल सिलेबस you could see here के the very first thing is to draw a relationship between normal, angle of incidence and angle of refraction. So हमने उसमें क्या बात की थी कि इंसिडेंट एंगल एंड रिफ्लेक्टेड एंगल टूवर्ड्स नॉर्मल होगा और अवे फ्रॉम नॉर्मल होगा. टूवर्ड्स नॉर्मल कब होगा? जब वो एयर टू ग्लास जाएगा, दिस वन. एंड अवे फ्रॉम नॉर्मल कब होगा? व्हेन इट्स गोइंग फ्रॉम ग्लास टू एयर. We discussed this formula, n is equal to sine I over sine R, and we had another formula which was sine R over sine I. ये कब था हमारे पास? जब हम ग्लास टू एयर जा रहे हैं. Then उन्होंने डिस्कस किया describe an experiment to show reflection of light by transparent block of different shapes. We will discuss this later. We discussed about the critical angle. Critical angle मैंने आपको बताया था कि that angle of incidence for which refracted ray makes an angle of 90 with the normal. Normally refracted ray कहाँ जाती है? Into the other medium. But no, that incident angle would be known as critical angle if it's making an angle of 90. The refracted ray makes an angle of 90 with the surface. Total Turner reflection भी हमने उसी के context में discuss किया कि when incident angle is greater than critical angle, light would reflect back to the same medium instead of refracting. This is known as total internal reflection, and their uses we would discuss in the next lecture along with the lenses. Now let's get back to our syllabus 0625. Again, the exact same thing. Define and use of normal, angle of incidence and refraction. Show with the help of diagram different shapes of refraction, how the reflection would be affected by different shapes, or describe the passage of light through a transparent material. हमने वो incident refracted angles draw किए. Describe the meaning of critical angle and refractive index. It has a formula of n is equals to C over V. N is equals to sine I over R. This and optical fiber use, and this point we would discuss in detail again tomorrow along with the lenses in the next lecture. If there is any question left, you guys could ask me later after the class, and that's it for today regarding reflection of light. अच्छा, if the objective placed at this point, image किस point पे form होगा? B, C या A पे? Ahmed. At which point the image would be formed?
Image will form where?
Yes.
At okay. A पे फॉर्म होगी नहीं हाँ A
A पे फॉर्म हो गया, B पे कितनी अभी रिसेंटली क्वेश्चंस किया है कि ऑब्जेक्ट एंड इमेज विल ऑलवेज बी इन लाइन एंड परपेंडिकुलर टू ईच अदर.
yes.
And what would be the actual time in the clock, Fatma? It's showing 2:35 right now. What would be the actual time? The image is formed by the she joined the class. Anyhow, Shazir बता दें, Ahmed बता दें. What would be the actual time?
मतलब इसका मिरर बताना है.
मतलब इमेज बन, हाँ, इसका एक्चुअल टाइम क्या शो रहा होगा?
इसका एक्चुअल टाइम होगा 9 डी आंसर होगा 9:25.
वेरी गुड. Because lateral invariant होती है, हमने इसको इधर स्विच कर देना है. So when we'll switch it here, the only option which is closest is 9:25. Let's not focus on the minute hand, but obviously अगर ये यहाँ पे switch होगा तो ये इधर switch होगा. तो ये 9:25 का टाइम बनता है एग्जैक्टली हमारे पास. ठीक है. आगे रिफ्लेक्शन था. रिफ्लेक्शन को बड़ी डिटेल में हम लोगों ने कर लिया हुआ है कि when entering from air to glass, incident angle would be towards normal, glass to air away from normal. If it enters at 90 degrees angle, it would go undeflected. This is the glass block, this is the ray box. इसके अंदर हम exactly यही image form करते हैं. ठीक है. Keep this image in your mind whenever there is a question regarding. अब मैंने आपको जो क्वेश्चन नहीं था, how would we find the speed of light in that medium, अब हम उसके अंदर यही सारा थ्योरी लिख देंगे कि हम रे डायग्राम की हेल्प से इंसिडेंट रिफ्लेक्टेड रे एंगल को फाइंड आउट करेंगे. We'll put it into the formula and this. And mostly due to refraction of light, object appears shallower than they actually are. Here is the formula of refractive index. N is equal to sine I over sine R. This is the kind of question shown कि जब medium, ये देखो, these two are parallel to each other, which means they are in the same medium. And जब इंसिडेंट मीडियम चेंज होता है तो हमारे पास दिस इज द एक्चुअल डेफिनेशन ऑफ रिफ्लेक्शन. Fracturing of light. It appears like shallower as it actually is. ठीक है? It is because of the change of the medias, and this is when the incident angle is equal to critical angle. The refracted ray makes an angle of 90. When incident angle is greater than critical angle, we get total internal reflection. There might be a theory written as well here. This is the normal case when incident angle is, ये हमारे पास नॉर्मल केस है जब हमारे पास इंसिडेंट इज लेस देन क्रिटिकल एंगल. सो रिफ्लेक्शन और रिफ्लेक्शन तो हो ही रही होती है. व्हेन इंसिडेंट एंगल इज इक्वल्स टू critical angle, we get this time making an angle of 90 with the normal, and when incident angle is greater than critical angle, we get total internal reflection.
सर यहाँ पे यही जो अभी आपने बताया है वो उसके अंदर जो है क्रिटिकल एंगल किस तरह, मतलब वो जो एक दफा वो फिगर दोबारा खोले मैंने उससे करना है.
ये
ये
वाला ही
वाली
ऊपर वाला
ये वाली, हाँ. इसके अंदर किस तरह इंसिडेंट एंगल लेस देन है.
क्योंकि ये लाइट रिफ्लेक्ट हो रही है. इट्स नॉट मेकिंग एन एंगल ऑफ 90 विद द नॉर्मल.
अच्छा सर, अगर इस तरह का
When,
सवाल आ सकता है
तो
कि
ये
वो
डायग्राम
बता
है
रहे
ना,
कि
वही
इंसिडेंट
तो
एंगल.
यही तो दिखाना. आप देखो यहाँ पे, अब यहाँ पे रिफ्लेक्टेड रे ने क्या बनाया हुआ है 90 का एंगल. इट इज पैरेलल. ठीक है. नाउ वी नो कि दिस वुड ओनली अकर इफ इंसिडेंट इज इक्वल टू क्रिटिकल एंगल. यहाँ पे
ओके.
रे वाज रिफ्लेक्टिंग लाइक नॉर्मल रिफ्लेक्शन जो होती है. दैट्स व्हेन द क्रिटिकल इंसिडेंट एंगल इज लेस देन क्रिटिकल एंगल. तो डायग्राम्स के रेफरेंसेस थे ना ए एंड बी को हमने, दैट्स हाउ आई न्यू कि नाउ इट्स इक्वल्स टू क्रिटिकल एंगल बिकॉज इट्स मेकिंग एन एंगल ऑफ 90 विद द नॉर्मल.
अच्छा, क्रिटिकल एंगल की इंडिकेशन ये है कि अगर 90 डिग्री बन रहा है तो फिर वो क्रिटिकल एंगल
हाँ,
कहलाता है.
रिफ्लेक्टेड रे का, रिफ्लेक्टेड रे.
सही है.
देन ऑप्टिकल फाइबर के अंदर जितना आपका, ये देखो यहाँ पे भी हमने ध्यान रखना है कि इंसिडेंट रिफ्लेक्टेड एंगल आपस में इक्वल होगा. ठीक है. दिस टोटल इंटरनल रिफ्लेक्शन इज ओनली अकरिंग इन द ऑप्टिकल फाइबर बिकॉज ऑफ द क्रिटिकल एंगल थिंग. And here again we 45 degrees pe when the ray enters, it bends at a 45 degrees. Similarly, here again 45 degrees, 45 degrees. You must remember these kind of diagrams. That how. This is the endoscopy. ये हमारा क्या कहते हैं उसको, ट्रैकिया जो वेंट पाइप होता है उसके थ्रू ऑप्टिकल फाइबर्स के थ्रू लाइट इंटर की जाती है in order to see the inner sides of the body. तो ये वही दिखा रहे हैं. This image is very important. ठीक है. These two images are important. You should know कि when an incident angle is at 45 degrees, that's how things happen. अब इसमें in which diagram, मैंने बोला which diagram figure ray of light is correctly labeled. Is it correct in A?
Water to air.
Ahmed,
फिर से बोलेगा क्या क्वेश्चन है.
which option is correct?
सर ये डी होगा.
Yes. Why is that? Because A में water to air जा रहा है, should be away from the normal, bigger angle होना चाहिए, but it's not. Similarly, इसमें away from normal हो रहा है, which is not possible. इसमें भी towards normal हो रहा है, which is not possible. So this is the only right option in which air to glass towards normal जा रहा है. देखो मैंने आप लोगों को क्या समझाया था कि trace this ray straight. ठीक है. जो एक्चुअल रे बनी हुई है उसको आप स्ट्रेट ड्रॉ कर दो. इफ द मीडियम इज डेंसर तो आपने इसके बिलो लाइन ड्रॉ करनी है. इफ द रे इज रेयर, द मीडियम इज रेयर, तो इससे ऊपर ड्रॉ करनी है. दिस इज योर clue that how do you need to draw these diagrams. The only thing that I can give an introduction to you today is the lens. There are two types of lenses. One is known as converging lens and the other one is known as diverging lens. are known as converging lens because and diverging lens because after passing from these lenses, the rays of light converge at a point and diverges after passing through the lens. Okay. This is the concave lens and this is convex lens. The point at which these rays meet are known as focus point. Similarly, ये इसका real focus point होगा because rays are actually meeting here. ये हमारे पास क्या होगा? Virtual focus point होगा because you could see here कि हमने इन rays को क्या किया है? Trace back किया to meet at this. But they both are known as focus points. Distance from center of the lens to the focus point is known as focal length. And this line which is passing through the focus point and center of the lens is known as principal lenses. Okay? And the center of the lens से light pass out होती है, it goes undeflected. It's everything is written here. Diminished image का मतलब ये होता है virtual and light images. Principal lenses. अब थिन एंड थिक लेंस के बारे में बात होती है कि अगर लेंस हमारे पास थिन है तो हमारे पास फोकस पॉइंट बिगर होगा, अगर थिन लेंस थिक है तो फोकस पॉइंट हमारे पास क्या होगा? स्मॉलर. There are three types of waves that we normally rays that we normally draw for the lens. One is K. If the ray is parallel to principal axis, it passes through the focus point. The ray passing through the center, it goes undeflected. The ray passing through the focus will be perpendicular, will be parallel to principal axis. These three rays you must keep in your mind. As you could see here, parallel to principal axis, passes through the focus, going from center, goes undeflected. Okay? You must remember these three rays. Which one is that? Lens, principal axis, object, focus point. Focus point should be equal at equal distances. First ray, parallel to principal axis, passes through the focus. Second ray, passing through the center, goes undeflected. Such type of images which are formed on the image formed on the other side of the lens are real images. Yani, if object is here and image is formed on the other side of the lens, such image are known as real images. ठीक हो गया? And other thing that we need to keep in our mind is कि जो real images होते हैं, they are always involved. Are you clear about this point बेटे? कि real and virtual images कैसे identify होंगे lens के case में? कि image which is formed on the other side of the lens are real and real images are inverted. That is object ऐसे image ऐसे form. And to decide magnified or diminished image. Diminished means small, light, deep. Magnified, larger image. In order to identify, we see the distance from the focus point. Lesser the distance from the focus point, lesser, magnified the image would be. And vice versa. अगर हम ऑब्जेक्ट को टुवर्ड्स फोकस पॉइंट लेके जाएंगे, we'll have a magnified image. अगर हम अवे लेके जाएंगे from the focus point, we will have diminished. and real images. Diminished means smaller images. Magnified and virtual images. Virtual image का मतलब ये होता है image formed on the same side of the lens as the object. जहाँ ऑब्जेक्ट हो इमेज भी वहीं आगे पड़े, such an images are known as virtual images, and as the images formed on the other side of the lens, such images are known as real images. Are you clear about the converging and diverging lens, बच्चों? Is there any question so far about the converging, diverging lens, focus point, center of point, principal axis, anything?
सर जो आपने तीन बताए हैं कि लेंसेज से यहाँ से गुजरते हैं, तो जो फोकस पॉइंट मतलब जो विदाउट डिफ्लेक्शन चला जाता है स्ट्रेट, वो
वो
उसका क्या
लेंस के
होता है?
सेंटर से पास आउट करेगा, वो लेंस के सेंटर से जो पास आउट करता है वो गोज अनरिफ्लेक्टेड। बाकी एक जो
तो
पैरेलल प्रिंसिपल
इमेज
है,
इमेज कौन सी किस तरह की बनेगी?
नहीं नहीं, वो तो हम टाइप्स ऑफ रेज डिस्कस कर रहे हैं ना। वो तो इमेज अगर फॉर्म हो रही है ऑन द अदर साइड ऑफ द लेंस तो वो रियल इमेज होगा, और फिर जब हम उसको ज्वाइन करेंगे तो वहां से पता लगेगा कि हाँ, उससे हम अंदाजा लगा सकते हैं कि इफ इट्स क्लोजर टू फोकस तो इमेज मोस्टली मैग्नीफाइड एंड रियल बनेंगे, अगर इफ इट्स अवे फ्रॉम द फोकस तो वो डिमिनिश्ड एंड रियल एंड स्मॉलर इमेजेस।
सर वो जो तीसरी वाली आपने बताई थी जो नीचे से जाती है, वो वाली कौन सी है?
तो ये थी कि ये थी कि अगर ये it passes from the focus point, let me use the scale. I forgot to add code. It passes through the focus. So after passing through the lens, ये क्या होगी? Parallel to principal axis.
सर फिर यहाँ से मतलब वो ऑब्जर्व कैसे कर रहे हैं?
So we started our lecture yesterday, and we were supposed to discuss lenses. मैंने lenses की basic definitions जो types थे वो बता दिए थे. Lens itself basically जो होता है, it is a large piece of clear plastic or glass with curved surface. Lenses are widely used in cameras, spectacles, projectors, and many other instruments. There are two types of lenses: converging lens and diverging lens, also known as convex lens and concave lens. ये जो कन्वर्जिंग लेंस होता है इसको कन्वेक्स लेंस भी कहते हैं, एंड जो डाइवर्जिंग लेंस होता है उसको कनकेव लेंस भी कहते हैं। As you can see in the diagrams right in front of you, K, when light rays passes through these lenses, they converge to a point. Similarly, when light ray passes through concave lens, they diverge out, spread out. ठीक है? Then we retrace these rays backward and they meet at a point. These points, both in convex lens and concave lens, are known as focus points. ये हम लोगों ने कल भी पढ़ा था, ठीक है? Where rays meet after passing through the lens is known as focus point. And converging lens का focus point जो होता है वो real होता है, एंड डाइवर्जिंग लेंस का फोकस पॉइंट जो होता है वो वर्चुअल होता है। एज यू कैन सी इन द डायग्राम, आपने इन रेस को रिट्रैक्ट किया है टू मीट एट दिस पॉइंट, दैट इज व्हाई इट्स फोकस पॉइंट इज नोन एज वर्चुअल फोकस पॉइंट। देन देयर हम लोगों ने कल ये सारे पॉइंट्स डिस्कस किए थे। ऑप्टिकल प्रिंसिपल एक्सिस क्या होता है? द लाइंस व्हिच पासेस थ्रू द सेंटर ऑफ द लेंस एंड द फोकस पॉइंट। द फोकस पॉइंट उन्होंने यहाँ पे इसको फोकल पॉइंट भी कह सकते हैं और प्रिंसिपल फोकस भी कह सकते हैं। द लेंथ फ्रॉम द लेंस सेंटर टू द फोकल पॉइंट और फोकस पॉइंट इज नोन एज फोकल लेंथ। एंड कल हम लोगों ने ये सारे पॉइंट्स जो थे उनको डिस्कस किया था। There are three types of rays जो हम लोगों ने कल डिस्कस किए थे. The one which passes through the centers goes undeflected. The ray which is parallel to principal axis passes through the focus point. The ray which passes through the focus points become parallel to principal axis. ये आपको तीन टाइप्स ऑफ रेज जो है अच्छे से याद होनी चाहिए. इसी की बेसिस पे हमारे इमेजेस फॉर्म होते हैं. एक दफा क्विक ओवरव्यू दोबारा दे दूं कि मैं हम लोगों के पास कितने टाइप्स ऑफ लेंसेज होते हैं. टू टाइप्स ऑफ लेंसेज होते हैं, concave and convex, and concave lens is also known as diverging lens. Convex lens is also known as converging lens. And there are three types of rays जिनको हम लोग डिस्कस करते हैं. The one which is parallel to principal axis passes through the focus point. The one which passes through the center goes undeflected. The one which passes from the focus before the lens becomes parallel to principal axis. Can you keep these three rays in your mind? That would play a very important role. Here, if this is the lens, focus point हमारे पास क्या होता है? Where all of the rays meet. It would be equal on both sides. Similarly, if this is 2 centimeter from the lens, यहाँ पे भी 2 centimeter होगा. Next focus point again किस पे आएगा? 2 centimeter. उससे next focus point किस पे आएगा? 2 centimeter. Distance would gradually increase from the center of the lens. ये 4 centimeter हो जाएगा. Third focus point 6 centimeter हो जाएगा. ठीक है? Can we go to the next point? फिर we discussed it yesterday कि हमारे कोर्स में कनकेव लेंस की जो है वो डिटेल नहीं है, वो ओनली स्टडी विद द कन्वेक्स लेंस. इसके अंदर आई गेव यू अ पॉइंट कि आप बस अपने माइंड में ये रख लें, व्हेन यू अप्रोच फोकस पॉइंट लेंस सॉरी इमेज start to magnify and becoming virtual. अब रियल और वर्चुअल का मीनिंग जो लेंसेज के केस में होता है वो डिफरेंट होता है. नाउ दिस इज अ रियल इमेज. द इमेज रियल इमेज जो है उसकी प्रॉपर्टीज होती हैं formed on the other side of the lens. सेकेंड प्रॉपर्टी क्या होगी इसकी? इन्वर्टेड. थर्ड प्रॉपर्टी इसकी क्या होगी? बल्कि बेसिकली हम दो ही प्रॉपर्टीज को डिस्कस करते हैं फॉर रियल इमेजेस. बाकी मैग्निफाई, do you think this image is magnified or diminished? Diminished और magnify का मीनिंग हम लोगों ने कल क्या पढ़ा था बच्चों? अहमद, what was the meaning of diminished and magnified?
सर मैग्नीफाइड जो कि मतलब ज्यादा क्या कहते हैं उसको, ब्रॉड नजर आती है, ज्यादा बड़ा नजर आता है,
मतलब
और
हाँ जी,
डिमिनिश
हाँ जी.
छोटी इमेज होती है.
Yes, 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 yes. Diminished is the image which is smaller than the object, and magnified is the image which is bigger than the object. ठीक है? So अब magnified या diminished decide करेगा कि how far away we are from the focus point. Not the second focus point, but the actual focus point. If we approach the focus point, image जो है वो magnify होंगे. और if we go away from the focus point, images जो होंगे वो diminished होंगे. Also, as we approach the focus point, virtuality increase होना start हो जाती है. Not exactly virtual image, exact virtual image will be formed when the object is inside the focus. ठीक है? I wouldn't, let's not write this कि virtual होना start हो जाता है. Virtual वो exactly तभी होगा when it will enter the focus point. Outside focus point वो हमेशा कौन सा image होगा? Real image होगा. Are we clear about this? Now, let's move to the other point. Sorry, what did I just do? अच्छा जी, you can see in the image K object is placed right here. First ray parallel to principal axis passes through the focus. Second ray passes through the center, goes undeflected. Image is formed right here. Now, there are certain images that we discuss. We do not need to memorize all these के image कैसे, बस we only need to understand कि image virtual होगा, real होगा या diminished होगा. If the object is placed somewhere at infinity, पहली ray as usual center, second ray passes through the focus parallel to principal axis, image is formed. Property क्या है? Inverted, real and diminished. Why is that? Because it is formed on the other side of the lens. When we have put the object closer, again parallel to principal axis, passes through the center, passes through the centers, go undeflected. The point at which the rays would intersect, वहां पे हमें image form होगा. Again, we could see the image is inverted, it's real and it's diminished. Diminished क्यों? क्योंकि it's smaller in size. Then, as we start to approach the focus point, we could see the size of the images getting bigger and bigger. अब रेस की टाइप सेम ही है. नो मैटर व्हाट वी नीड, देखो passes through the focus. जब आप फोकस के ऊपर ऑब्जेक्ट रखेंगे, image will not be formed. The rays would not meet at any point. When the object is placed inside focus, you could see here again parallel to principal axis, passes through the focus, goes through center. अब हम जब इन रेस को ट्रेस बैक करते हैं, they meet at a point, यहाँ पे हमारा जो है वो image form होगा. अब this image is upright, virtual and magnified. Are we clear how to draw the diagrams in the lenses? Then there are two types of correction that needs to be done. That is short-sightedness and long-sightedness. Long-sightedness is corrected using the convex lens, and short-sightedness is corrected using a concave lens. Long-sightedness में image is formed behind retina. So, in order to form that image on the retina, we use a concave lens, convex lens. As we could see, the rays after passing through the lens is converging. You must memorize these diagrams कि कैसे इनको draw करना है. There are two lenses, two convex lenses. The first one, let me go and see if there's some neat diagram, a clear one. Let me see if the diagram here. Okay, this is much better. अब यू गाइज नो कि हमारे आई के अंदर ऑलरेडी कौन सा लेंस होता है. कौन सा लेंस होता है हमारी आईज के अंदर बाय डिफॉल्ट? ये रेज की पोजीशन से क्या लग रहा है कि कनकेव होगा, कन्वेक्स होगा? शानजे,
Convex.
रेज कन्वर्ज हो रही है, डाइवर्ज हो रही है?
I don't know.
कन्वर्ज हो रही है, ठीक है. दैट मीन्स के कन्वेक्स लेंस नेचुरली होता है. अब लॉन्ग साइडेडनेस में हमारे पास क्या होता है कि इमेज जो है वो बियॉन्ड रेटिना जाके बन रहा होता है. हियर नाउ वी पुट द कनकेव लेंस, कन्वेक्स लेंस. मैं इसको फर्दर ऑन मैग्नीफाई कर देता हूँ. जितना क्लोजर दिखाएंगे उसमें आपको आइडिया होगा. यू कुड सी हियर कि अगर मैं इस रे को वो करता हूँ, इसका स्ट्रेट वेरिएंट कहाँ पे जाएगा? अगर मैं इसको, वैसे तो नजर आ ही रहा है आप लोगों को, इफ इवन इफ आई डोंट डू इट, के कैन यू सी कि कैसे लाइट कन्वर्ज हो रही है यहाँ पे? क्लियर हो रहा है आप लोगों को कि here you could see the light is converging and then light is converging again and the image is formed at retina. Two converges हो रहे हैं हमारे पास. After passing through the lens, one converge, and after passing through the eye, second converge, and image is formed at the retina. You must memorize these diagrams. Whereas short-sightedness इसका opposite होता है. Short-sightedness में before retina जो है वो image form हो रहा होता है. For that, we use concave lens. The image looks somewhat like this. The image is formed before retina. Again, for that we use concave lens. Concave is a diverging lens, so it diverges the light after it passes through the lens and then it converges up till it meets at the retina. So short-sightedness ki diagram and long-sightedness ki diagrams you must memorize and their respective definitions. Long-sightedness basically क्या होगा? करीब की नजर खराब होती है और short-sightedness दूर की नजर खराब होती है. Definition उसकी यहाँ पे लिखी भी हुई है. A long-sighted person sees distant object clearly, but close object appeared blurred, which mean closer is difficult to form. And short-sightedness, it's the opposite. Person sees near object clearly, but distance objects appear blurred. And the respective uses you need to understand. Then there's this linear magnification that you have started in the bio as well. Length of image over object length, or height of image over height of object, distance of image over distance of object. Either case, you could use the values. For example, either I can use this height and this height and divide it with each other, or I could use the distance of object and image from this lens to find out the magnification. Magnification का term, as the term indicates, magnification का मतलब क्या होगा कि image कितना magnified है than its real values. ठीक है? Are we clear about long-sightedness, short-sightedness, how the lens images are formed and everything? Dispersion of light is basically the spreading of white light into its component color. The definition is written here. Due to difference of medium, so a band of color spectrum is obtained. The effect is termed as dispersion. So dispersion is basically the spreading of white light into its component colors due to the change of medium. अब हमने उसके लिए विबग्योर पढ़ा हुआ है. स्पेक्ट्रम हमने रेड लाइट का इलेक्ट्रोमैग्नेटिक इंडक्शन में पढ़ा भी था कि सबसे टॉप पे रेड होता है एंड बॉटम पे क्या होता है, cause this reflects the most and this reflects the least. Whenever they ask us to draw the diagram, we would go according to this image. For example, if it's between orange and red, orange would be at top, red yellow would be at bottom. If it's between yellow and green, yellow would be at top, green would be at bottom. If it's between green and blue, green would be at top, blue would be at the bottom, and respectively जो उसके रेनबो के कलर्स होते हैं हमारे पास. यहाँ पे उन्होंने वो सारा सीक्वेंस ड्रॉ करके भी दिया हुआ. Okay, that's all about light. Let me take you to the syllabus and see whether we have covered everything or not, and then I will show you how what kind of a lens question comes in our exams and how do we need to solve it. Okay, correct. अच्छा, I'm showing you from the syllabus now कि हमने जो points अभी discuss किए हैं, and that would eventually put an end to our wave section completely. The very first one you could see here, describe the action of thin converging lens and diverging lens on a parallel beam of light, जो मैंने आपको यहाँ पे दिखाया भी था कि converging and diverging lens की properties ये वाली, how does the lens work, और I guess यहाँ पे था, मैं साथ साथ एक दफ़ा दोबारा भी उसका व्यू आपको देता रहूँगा so that you guys could understand के here के thin convex and converging and diverging lens, how these particular lenses work. Define the term focal length, principal axis and principal focus. मैंने आपको तीनों definitions दिखा दिए हुए थे in both the books. Principal focus, focal length, and here principal axis, the line that passes through the center of the lens and the focus point. Optical center, the midpoint of the lens. Principal focal point, the point at which the rays actually meet. And principal axis हमारे पास सारे ये तीनों definitions उसमें cover up हो गई. Then we have draw ray diagram to illustrate the formation of real and virtual image by converging lens. Converging and diverging lens के against मैंने आपको images दिखा दिए थे. This table के this is the virtual image and this is the formation of real image. Any diagram you could draw. Inside focus put करेंगे तो virtual image form होगा, outside focus put करेंगे तो real image form होगा. Then we have linear magnification. अभी recently मैंने आपको दिखाया and it's वो describe the use of single lens as a magnifying glass. Magnifying glass basically when you place the object, ये होती है उसकी ray diagram. Remember this is the ray diagram for this one. Yes, Ahmed?
सर स्क्रीन शो नहीं हो रही, पुरानी आपने पेज खोला हुआ है बुक का।
हाँ जी सर, क्वेश्चन नहीं आ रहे
Oh,
आपका।
सॉरी, अब नजर आ रहा है?
यस।
तो जब आपने मैग्नीफाइंग ग्लास की डायग्राम बनानी है तो आपने ये वाला बनाना है, इनसाइड द फोकस ऑब्जेक्ट को पुट करना है एंड एग्जैक्टली वही रूल फॉलो करना है. पैरेलल टू प्रिंसिपल एक्सिस, passes through the focus point, passes through centers, go undeflected. आप रेस को ट्रेस बैक करेंगे एन इमेज फ्रॉम this is for the magnifying glass. Then उसने बोला है रे डायग्राम टू शो द फॉर्मेशन ऑफ इमेज इन द नॉर्मल आई, शॉर्ट साइटेडनेस एंड लॉन्ग साइटेडनेस. मैंने अभी आप लोगों को वो रिव्यू करवाया, लॉन्ग एंड शॉर्ट साइटेडनेस. This is the short sightedness. We make the diagram like this. आपको ये डायग्राम भी बनानी आनी चाहिए, ये डायग्राम भी you must know. And long sightedness के लिए ये this we use convex lens, for short sightedness we use concave lens. Then we have describe the use of converging and diverging lens to women. I just showed it to you. We discussed the dispersion of light through the prism और कैसे उन colors ने form होना है, which would come at the top, which could come at the bottom, all of these points. Moving on to the other syllabus. Again, describe the action of convex lens and diverging lens. Was same point. Define the use of the term. Same point. Ray diagram to the formation of real image by a convex lens. Same point. Characteristics of image using वो जो मैंने आप लोगों को यहाँ पे दिखाया था, सेम साइज होगा, वर्चुअल होगा, enlarged होगा, कब सेम साइज बनेगा, ये वो सारा पॉइंट. Virtual image की formation through converging lens. Describe the use as a magnifying glass. Same point. Virtual images formed, extrapolated वही जो मैंने आपको दिखाया अभी, and converging and diverging lens for short sightedness and long sightedness. ये जो virtual point is formed when extrapolated backward ना, वो यही वाली है कि जब आप रेस को backward लेके जाते हैं, this is known as, ये extrapolation इसको कहते हैं, when you मतलब retract it. Then हमारे पास क्या है यहाँ पे, मैग्नीफाइंग ग्लास की वही जो अभी अभी इमेज मैंने आपको दिखाई, दिस इज फॉर द मैग्नीफाइंग ग्लास, ये वाली इमेज. एंड व्हाट डू वी हैव नेक्स्ट? शॉर्ट साइटेडनेस, लॉन्ग साइटेडनेस की करेक्टनेस, वी डिस्कस्ड इट and this is exactly the same point in both the syllabuses, that dispersion of light using a white and how white light split into its component color. And monochromatic light is a light of single frequency. Single wavelength, single frequency is known as monochromatic light. So we have reviewed the syllabuses as well, and that concludes the light section. And if you guys have any question from anything, just let me know of it. Word we left in the previous diagram. अब इसमें हम लोगों ने क्या करना है? इज द इमेज रियल फॉर्म होगा या वर्चुअल फॉर्म होगा? बताइए शानजे, वर्चुअल इमेज फॉर्म होगा, रियल इमेज फॉर्म होगा?
एक सेकंड, रियल वर्चुअल
वर्चुअल होगा। अहमद, क्यों वर्चुअल होगा?
सर मुझे डायग्राम ही नहीं समझ आ रही।
क्या समझ में नहीं आ रही?
डायग्राम की कैसे है, मतलब प्रिंसिपल एक्सिस।
ये लेंस बना हुआ है, ये ऑब्जेक्ट पड़ा हुआ है, ये फोकस पॉइंट है। व्हाट इज देयर टू अंडरस्टैंड?
ऑब्जेक्ट पी क्यू है या लेंस है?
यस, पी क्यू ऑब्जेक्ट है। पैरेलल टू प्रिंसिपल एक्सिस क्या करेगा वो? passes through the focus फोकस पॉइंट कहाँ है? ये रहा फोकस पॉइंट। ठीक हो गया, ये मैं ले गया और इसी को मैंने ट्रेस बैक कर लेना। दूसरी लाइन which passes through the center goes undeflected, ये मैंने ड्रॉ कर दी। लाइन which passes through the center goes undeflected, इसको भी ट्रेस बैक कर दूंगा। तो ये कहाँ पे आके मीट करेंगी? इसको मैं थोड़ा सा और कर देता हूँ, ट्रेस बैक थोड़ा सा। They are meeting right here, यहाँ पे हम इमेज बना देंगे। The rays were there meeting, वहां पे हम इमेज ड्रॉ कर देंगे। So the image is virtual, upright and magnified. Clear? Are we clear बच्चों?
यस।
Now let's move to the next question. Lens का, वो it was at the very beginning. Then we skipped another question of lens. It was right here. अब उसने कहा हुआ है the focal length is 5 centimeter